We're at the Yas Marina circuit in Abu Dhabi to have our first look at the McLaren P1, and we thought we'd have a really close look at all the incredible aero and the technical details of the car. We're with Paul McKenzie, who's the P1 Programme Director, so it's his baby, so there's no better guy to tell us about the car. So Paul, can you take us through? We'll have a quick walk around.
Of course, yeah. So the design of the car is really driven by aerodynamics. That's really sculpted the whole vehicle. So even these details like this nose section here, it's all about getting clean air up into the engine intake on the roof. And for the main cooling, we've actually got our intake on inside the doors. You can see this huge duct down here, and it's all about getting good clean air up over the fender. So we're not getting an interruption of any of the dirty air coming from the wheel arch. So really good quality air down in here. Over the back, you can see in the ticks, they're actually the clutch coolers. We've got on both sides.
Okay, so you've got a further intake.
Further intake, yeah. So it's all about managing air. 900 horsepower. It needs a lot of air to feed it. It generates a lot of heat, so we've got to get rid of that. Rid of that heat as well. And of course, we've got the different settings. So we've got it in race mode here. We're right down on haunches, so it's down 50 millimeters from its road settings.
50 mil?
And you can see how close it is here.
Yeah.
You can't drive on the public road like this. It really is too low. So sleeping policemen and things would be a real problem. But also, it's gone down so low, it's actually taking it away of the legal settings. So the headlights, the pedestrian impact are actually away from
So it's way more extreme than you could otherwise do.
Absolutely. And the rear wing actually sticks out as behind the car.
So this is on its maximum downforce setting at the moment.
And that actually works, it goes up, but it also pitches. So it's actually got a pitch movement of about 29 degrees.
Yeah.
And so you've got the DRS function. So on the steering wheel, like in the Formula 1 car, you come out of the corner, you press that, and that flattens off as well. But actually, if you're going over 160 miles an hour, it actually knows that you're going fast. It'll actually start backing off.
So it will do that itself, or you have the option to do it.
Now, as soon as you brake or put any steering input in, it'll pop back up.
Yeah.
So it's acting as an air brake. Now, because we've got that, and you've got a big surface at the back of the car, that would change the driving balance of the car. So we've actually got tucked up under the floor.
Yeah. Which you can't actually see.
There's flaps which are working in conjunction with the rear wing to make sure.
So they're always
balanced. That's right. So yeah, I mean it's the geometry is really driven by the aerodynamics of the car.
Did you do a lot of the aerodynamics in CFD, so in simulation, and then you've verified that with road testing?
Yeah, so we started in CFD. Our chief aerodynamicist, Simon Lacey, actually joined us from the Formula 1 team way back in late 2009 when we kicked off the programme. So he brought a lot of Formula 1 technology. A lot of CFD was run to start with. And then, of course, we're going to the wind tunnel and then onto the car. And it's when you get into that you start seeing the subtle differences between the CFD. And so, for example, what we found was this was actually quite a late addition to the car.
Yeah.
We found that we weren't getting the efficiency of the radiator in here because of the turbulence here, and we didn't see that on CFD. So actually this was a late addition, and that's why you're...
But it's quite an honest shape then, isn't it? Everything has a function, although it's quite stylised in certain areas.
Yeah. So what we did is we actually had the aerodynamicists and the engineers sitting in the studio with the designers. So rather than just giving the designers that free hand of sketching, we had those three functions actually in the studio. So the back of the car is probably one of the most dramatic areas.
It is amazing, isn't it?
It's just huge rear diffuser.
Yeah.
And you can see where we have the back end is open, and that's all about exiting the hot air as well. And on the top we have the titanium cover, and again this is all about getting the right air out. Yeah. And actually here, this is actually a chimney.
That's another vent there.
So that's actually another vent here. So it's actually, you can feel the heat coming out of there.
But it's still quite enclosed though, isn't it, compared to like a 918 Spider or something, which is basically the whole back end of the car on the deck lid. You're extracting far more from here.
Absolutely, yeah. And I mean, the design really is shrunk wrapped. And so when we first conceived the idea, we actually took all the engineering hard points and actually just put the closest surface to those hard points.
The way the back of the car is so low, it's a totally different look to any other supercar you've ever seen, I think.
Yeah, when you see how low it is. And you really see the aerodynamics working in this configuration in wet conditions. The big rooster tail that you get is stunning. So that works really well. There's
terrific purity and functionality in the shape, but then you've got some really distinctive details, which probably the most striking one is this tail light, isn't it?
Yeah, the rear lights, I'll turn them on. It was actually one of the first penned lines on the styling. So Frank Stephenson did this great,
just a flourish, and that's what you've. There you go.
It's
they're
great
on.
that it's actually
that is
really materialised. And when you follow the car at night,
it's totally unmistakable, isn't it?
Yeah, and it actually does peter out, and that's by design. But again, we needed a very thin light, so it didn't interfere with the cooling at the back of the car as well. So they are incredibly thin on the rear clam to open up.
And what materials? When you've got the heat shield for the exhaust, you've got this mesh. Have you had to use any special materials or processes to protect the car? Or
so the bodywork is all carbon fibre. Obviously, got the visual carbon fibre. All the bodywork itself is carbon fibre. We've got titanium on the heat shields, the exhaust muffler, titanium. And titanium up here, so we're using quite some exotic materials. There's an aluminium mesh. This was really designed about getting. It doesn't block any air.
So it's minimal resistance for
resistance. So even that has been designed in such a way to make sure that we actually minimise the effect. So it really is. Everything is designed for a function. But also there's some lovely engineering detail on here. These are big, meaty posts here, but it's 600 kilos of downforce.
It's a huge amount.
Taking quite a lot of load.
Yeah.
The wheels, we're using super aluminium.
Right.
It is.
Wouldn't use normal aluminium.
No, it's super alloy, and it just gives us a 10% weight saving on standard aluminium. So it's so everywhere we can.
And that's where it counts most, isn't it?
Absolutely. Everywhere we can, we've tried to maximise by using the right materials.
And the brakes are pretty special as well, aren't we? We can come around this side.
Yeah, the brakes we developed with Akabono, our Formula One partner, and they are quite interesting as much as they go almost a mirror finish.
They do look totally different to any other carbon.
Yeah, they're a carbon ceramic, but they actually have a silicon carbide coating on them, and the stopping performance is fantastic. Not just on the track, but actually on normal street driving, you get good feel, which is obviously a problem you can't get with these types of brakes. So they're fantastic. Work really well.
And you haven't chosen to have regenerative braking, it's just on overrun.
Our target for the car was to produce the best driver's car. So anything that we felt interfered with the balance of the car, the feel of the car, we investigated it all up front, but when we looked at regen braking, it actually is very difficult on the calibration and on the feel to get it right.
I think you can always feel a step.
That's right.
When it engages and disengages, can't you?
Yeah. So we've got when you lift off, you get regen on lift off, but not on braking.
And that's enough. For the range that you've got, the capability you've got in this battery, that's enough to keep that topped up, isn't it, I guess?
Yeah, that's right, yeah. And the range on here, on a full battery, you'll get over 10 kilometres of range. So, and that's 10 kilometres is when you're going, 30, 50, 70 miles an hour, the NEDC cycle. So if you're just pootling around town, you'll get more than
or traffic jams,
yeah. And actually driving in that configuration, it's actually very relaxing. It's a big engine, it's a big throaty engine, so sometimes you actually just want a bit of quiet. You press the EV button, it all dies. But we've got there's a whine that comes from the gearing system.
Because the motor drives through the gearbox, doesn't it? So it's not a stepless.
That's right, and so you get this whine. It's a bit of a sci-fi sound, but it steps up with the gears, and it's a great sound. It feels appropriate for what you're doing with the car.
Thanks very much for that, Paul. I hope that's given you a flavour, at least, of some of the details of the car. We'll be driving it later, and I'm so excited. I can't wait.